We've seen how you can simulate the DC operating points and get the results from that analysis printed on the schematic itself. That's very easy. What happens if you wanted to, for example, plot a graph of the voltage on the collector for a range of different values of BF, the current gain of this transistor? Well, actually, that's quite straightforward to do and very useful. You go into Simulator and hit Choose Analysis, and this time, as well as the DC operating point, we're going to do what's called a DC sweep. Select the DC tab so we can set up what we're going to do, and we're going to hit the Define window. That brings up this. We're going to use a model parameter as what we're going to change between the different runs. It's asking us what the model name is. Well, the model name is BC546B-Q1. Hyphen Q1 because it's not the library model, it's the user model that's been modified from the library model for that particular transistor Q1 in the circuit. And the parameter name is just BF. You'll see it comes up there. Hit OK. We want the start value. Well, let's start with a current gain of 100 and go up to a current gain of 500. Actually, we'll start from 120 because that's what the values, that's the range of values suggested in the data sheet for this transistor. Number of points, 50, and linear tells you that those 50 points are being picked linearly between the start and the stop values. We've clicked this to tell it to do a DC sweep, and we could either just click Run here or click OK and then go to Simulator and click Run. Happened so fast you probably didn't see the little window coming up there telling you it was going. We now want to look at the output, so that is under the Probe menu. We go Probe and Add Curve, and it asks us what we want to plot. Well, what we want to plot is VC. You can now, I hope, see the reason why I gave that node a name. I don't have to try and figure out what that node is called by the simulator. I can just refer to it by the name I gave it, VC. It knows what the x-axis is going to be because it knows that we've just done a DC operating point sweep. So I can just hit OK, and I get up this window, which is a plot of VC in volts against the BF value, which is the current gain from 120 up to 500. And as expected, it's a linear straight line downwards. That's it. Quite useful. We can also do things like do DC sweeps over temperature, and that's done like this. Choose Analysis. This time we're going to go not over a model parameter, but temperature. And start temperature. Let's start at 0 degrees C and go up to 150 degrees C. 50 points again. Hit Run. Go back to Probe, Add Curve. What do we want to see? VC again, but this time plotted against temperature. And now we get this graph. Temperature in Celsius from 0 to 140, and you'll see that the simulated circuit does have a temperature dependence. The voltage on the collector is expected to decrease very slightly, only by about 30 millivolts or so, between 0 and 150 degrees C. Supposing I wanted to plot the collector current against temperature. How do I do that? Well, the same analysis works fine. Mode temperature, start 0 to 150, number of points 50, and make sure DC sweep is enabled. However, probing it, what we want to do is probe the collector current. Now, under available vectors here is a list of everything that you can probe. The items with the hash in them are currents. So that's the input current to the input capacitor, output current from the input capacitor, and so on. If I look at Q1 hash C, that means Q1 current collector. That's what I want. Hit OK. And there's my graph of collector current in milliamps against temperature.